So today I would like to discuss. It is actually a continuation of that previous lecture. I would like to start from that particular means statement or means I would like to continue the discussion that we had to stop that discussion in the last day due to shortage of time. Today our main focus is on V card and O card. Although these between these two, the O card uh, is means V card. We generally use V card more than that of O card. So how to get O card from O card and V card from this one? Last day we have discussed this diagram. So, before I proceed, let us just quickly revisit how we started this diagram. It was like we start from power equation, this, that, and then we draw like we take a point on this horizontal axis. Uh, just a minute. We take a point O here on this horizontal axis, and then we take means we draw a line vertical to that with the length of that line is it was V by 2R, and this length was 90 degree with respect to this line, and then we draw a circle eventually means, and it was quite obvious that the circle will pass through this point O, and that this horizontal line from where we started our drawing, now it will behave like a tangent to this one, to this entire line. Now this line when we consider, we have shown that this one is our like since this one was V by 2R, obviously the dia of this circle will become V by 2R, and we have further proved that this is the circle corresponding to zero power, that is the outermost circle or the largest circle that we can have in such a way that is also tangent to this point, means for the circle for which this line acts as a tangent is a zero power circle. Now we can form different concentric circle, and for them what we can have different values of like current. Depending on the load power factor, we can have different values of current. Here you can see theta 1 and theta 2 are the two different value of load power factor for which we are having two different value of current for same load. Try to understand that when we are talking about this load means the external load. Suppose this is your generator, these are the three terminals, and this is your load. So while mentioning V means this voltage corresponding to line voltage, and this theta 1 theta 2 all are load power factor. So obviously these circles represent unity power circle, means not unity, rather what to say it, on this circle it is like your equi power circle. Means like you have studied equipotential line or equipotential surface. Here it is like equipower circle. On each point of this circle, your power is same. However, the and obviously if you join O with that, you will get the value of current. Uh, and also it is like I1 I2 you will get different value. Here all these currents are, you can see that all the currents are lagging this theta 1 theta 2. And why this is we are taking it from this V by 2R, that is also clear. Now see, as I have discussed, although we are talking it means trying to like give you a picture where we can get the different value of current for same load and different power factor. These actually these circles are drawn in the plane of current. This is actually current plane, means in ampere, because current can have two different meaning. And all these lines, means these circles, concentric circles, are equipower circles. Like on this circle, every point is that it's having equal power. Now from this point O, we draw a line, rather drew a line V by ZS, and obviously that V by ZS will lag V by R by an angle gamma, where gamma is equal to tan inverse R by X, or sorry, X by R, right? Because it is like your impedance triangle. This one is ZS, this one is, the vertical side is Xs and the horizontal side is R. So obviously this gamma will be here. This is the angle gamma. Now we are drawing this V by ZS, and this line, the arc of length V by ZS and centered at point O, intersect here at point B. Now from B we can further draw concentric circles where the circle's radius is governed by E naught ZS. So this E naught ZS is very important. If you move, however, unlike the previous case, here if you move outward, you are going to consider a higher value of excitation. In this case, if you move inward, you are about to consider a higher value of power. But here in this case, if you move in outward direction, in case of this excitation circle, if you move in this direction, like this one is having more higher excitation value than this one. Although we are not considering the excitation voltage directly, rather we are doing a kind of proportion. We are taking a proportionate value, and that value is proportional to E naught by ZS. Being a constant impedance ZS, this E naught means for different value of E naught, the corresponding, I would like to use the term vector, will also be scaled accordingly, right? But and all the vectors are being shifted by an angle negative gamma, so there will be no such change in terms of relative phase. Well, now here we are considering different values of E naught. even you can figure out that for a given power circle, interestingly, we can have what? We can have two means terminal value of E naught, like we are drawing it. Let me try to draw two terminal cases. Say one like this. Suppose I want this PD1. This is my power requirement. So this can be one value of excitation, and another value of excitation can be what? Can be like this. Just a minute. So for a given power, we can have minimum and maximum value of excitation. Now, also we have studied that for a given power and given excitation, how we can have the value of current, what would be the value of current, that will be means governed by this one, like for two different power factor, how we can have uh, two different values of our uh, means for same excitation, uh, having two different value of power factor will give us two different value of delta 2. Now if you find this one is a bit tricky, like how this one is becoming delta 1 or delta 2, then one thing you can do is that, just let me draw the diagram. So well, I have drawn the diagram. Just a minute, let me just change the volume level so that you can hear me more clearly. This is 2 a.m. so I cannot means cannot be very loud, cannot shout at the top of my voice, because otherwise my neighbors will raise a complaint to that housing society. Anyway, what these two diagrams I was drawing, and this is very important here to note that this is delta, this is theta, and this is gamma. Gamma and all these are specific to this particular case of this synchronous machine. Now, let me do a small thing, like what would happen if I start the essence of drawing this one in this way is just to show you that now you can take it here to figure out that how your epsilon z is, all these things are there, you can figure it out. Anyway, so let me just try to rotate this one. So if I try to rotate it in this way, yeah, so here So now I have inserted a second image. You can see here that if we just tilt it in that way, we are going to get an image like this. Like the previous diagram, if you tilt it, means previously it was like OB, and now we are getting this OB here. See what is that the motto of this diagram, or better to say that intention behind tilting that circle, and what I am trying to establish here is that I would like to find out the relation between armature current, which is a dependent variable for a given power, and for different field excitation. So here you can see that this is I have taken a projection of that, and we are trying to do it. So here in this graph, it is only variable, means independent variable is field excitation and armature current. Now obvious question that may comes in your mind that we have discussed. Okay, let me just explain the construction first, otherwise things will become difficult to understand in later. So what is happening here, let us consider a particular circle. Say we know for different circle we are having different values of power. So let us consider this circle PD1. Right. Now, as we know that for a given excitation value, say this one, this is a particular value of excitation given by which value, that is E naught by ZS. E naught is your excitation, that is proportional to your IF. Here from the book which from in that book from which I have taken this diagram, they have tried to establish something like E naught is equal to K, that kind of things. But it is easy to understand that for a given E naught we can have two different value of current. So the two different value of current is like, one is this color is not very clearly legible. It is, so we have two different value of current, that is I2 and I1, right? So here what we will have, here for this I1 and I2 we will find they are corresponding. This is in the entire diagram is in your current plane, but this one, this plane is in Cartesian plane, right? Well, so if this is in Cartesian plane, then what we can consider that is quite clear. The Cartesian plane one, like we know, we used to plot in our early days x versus y or y versus x. So y is the dependent variable, x is the independent variable. So here armature current is placed or plotted along our vertical axis, while the independent variable field excitation or field current is plotted along horizontal axis. Now for these two values, like here for I2, what value you will get here? I2 you will get 1 point like this. For I1 you will get another point, like how to draw I2 here. Here the magnitude is 0. So from this you just follow I2 and then you draw I1. These I1 and I2 are drawn as per means they are scaled, like depending on their magnitude. Here in this Cartesian plane I am drawing I1 and I2. Now for this excitation we are getting two different value of I1 and I2. So they gives us this is the two extreme value I1, I2. Now here we must not overlook a factor that can you tell me which one is leading, which one is lagging? Obviously this V by R, this is our guiding line. If someone is in means if some current phasor is in this way, then it is lagging. So I2 is lagging, I1 is leading. And now see that, just let me check whether it is recording or not. Every time I am afraid of this because long back I had a pathetic experience. Almost after 1 hour I discovered that nothing got recorded. So that is a kind of apprehension always, or fear always onto me. Now we are talking about this circle PD1. Now this is not the only one value of I1, means one value of excitation that is intersecting with this. Rather we can have different other values of I1, I2. Say if we take this line, now obviously here also you can draw your two currents. Say this is our I1 dash, this is going to be I2 dash, right? So I1 dash and I2 dash, you got it. So we can plot here that you will find this is the value of I2 dash, this is the value of I1 dash. Clear? Now another one, if we take, suppose this gentleman, so what you will have here? You your I1 dash and I2 dash, right? So this is our I1 double dash, I2 double dash. So this is I2 double dash, I1 dash. Like it is difficult for me to draw this diagram in scale, so I am trying to show you that how we can construct this diagram. Like we can take different values. Obviously here this B is the center of the circle where E naught is equal to 0 at B, and if you go in this way, then you are taking higher value of B, sorry, E naught, higher value of E naught. So this direction, if you move outward, you are taking higher values of E naught by ZS. Now this one that we are having here, now let us take another value, then we will be able to. So another one could be here, that is I1 triple dash and I2 triple dash. So what would be I1 triple dash and I2 triple dash? This is I2 triple dash. This is your yeah. This is your I1 triple dash. So basically, after having all these points, what you can do, like if you take a small interval, like by interval I am mentioning this gap between two consecutive value of E naught that you are going to take, you will get different such point, and after obtaining all those points, if you join them, you will get closed contour like this. This interestingly, this represent all the values of armature current for different field excitation. However, along this curve, what is the genesis of this curve? From this red colored circle that is having a constant power PD1, you are getting, for constant power we are getting this kind of representation when we are considering this, right? So interestingly, you can see that this side, if you consider like all this side where obviously the minimum value of current is for unity power factor. So the for each they will form, like here they are concentric circles. So for each of these concentric circle, you will get different power, means like for an circle, for a circle like this that is interior to the previous one, you will get a kind of ellipse kind of shape that is interior to the previously drawn red curve. You will get a family of this kind of curve. So these curves indicate different power level. You can say also power contour. On each point you are having different value of current, power factor, but same power. Means all these, say this red, along this red you will get different power factor, different field excitation, different value of armature current, but the means power, electrical power remains same. And vice versa, if you consider the mechanical power will also form proportional envelope. Why I am claiming so? Because for every point you can understand, like if we disregard the constant loss for an electrical generator, it is PE plus I square R if we are talking about per phase condition. So for a particular, for every current point, what would happen? The your PM will be just for every point you will get a proportional amount of shift. So there will be you will get a curve PM. From this one you can figure out another curve that is just slightly shifted. Well, now for this power curves, what is interesting, that how can we figure out, I will tell you that particular point of unity power factor, but what we know that for unity power factor current is minimum for a given power. What I am trying to say, P is equal to Vi cos theta. So V is constant. If we keep P constant, then making cos theta is equal to 1 will ensure I minimum, right? For a constant P, if we can make cos theta is equal to 1, then I will become minimum. So for all these curves, what would be the point of unity power factor? This is the point on this red curve for which you are having minimum current. Similarly for this brown curve, you must have to figure out the point for which is like which indicates minimum value of armature current. Similarly for this green contour, you have to figure out, and if you get this kind of curves, all these curves, if you join them, they will give you the condition of like your minimum power unity power factor operation, right? So all these curves if you join you will get, and obviously then you need to extend because like everywhere it is not, but if you extend them you are going to get a curve like this. Now interestingly, that unity power factor curve, just suppose if we take this red one, right? So here this curve is going to means like divide this in two zone. Anyway, first come to O curve. So undoubtedly all these curves what we are having here, if we see that they are giving us the shape of closed contour and can be written like the English alphabet O. Like if you just tilt it, say what kind of curve we are having here. Let me draw this green curve here. Right. Now, if I just try, let me try whether I can. It is unfortunately selecting the whole image. Anyway, so I'm not able to do it properly. But if we can tilt it, you can also understand that it is not a rocket science. That you will get a O shape like in English alphabet O. So that is this family of concentric ellipses. You can say we call them O curve. And then what is our V curve? V curve is that if you just cut O, say this is our O, and then you just cut it in this way, then what you will have? Like let me draw it into. Then you insert a cut along this. Then what you will have? This will give you the shape of V. So similarly here all these are giving, if you take a particular section, they are going to give you the shape of V curve, right? Now obviously a few things we must not forget, that is related to our stability limit. We know that our uh, delta should not exceed that means gamma, and gamma is our armature internal angle, that is tan inverse xs by r, and delta is the power angle between E naught and V. So means we can do anything, but we have to keep it in our mind that if delta is greater than gamma, then our system will start behaving in an uh, uncontrollable manner, right? So those are the things you can have here. Now, well, so this is V curve and O curve. Now we'll investigate about condition for uh, means unity power factor. So here in this diagram, one thing is very clear to us that we can understand from this diagram, that obviously this, as I said, that this one is giving us this B by R is giving us that condition. Now see that this leading and lagging current, they are actually this like so here you can see that we will get for minimum value. Now we are having this current. I mean for an excitation value F1, that is giving us the, just a minute, yes, huh. For an X, oh God. Huh. For an excitation value F1, we are getting this amount of current, for which we are having power factor is equal to unity, and for this also we are having for two different excitations we are getting two different value of current, for which we are having unity power factor. Now the obvious question that should comes in your mind, that if we are having such kind of things, like, sorry, not this one, say this is one, and one value of current, the other value of current is this much. So now obviously for one, like if you understand that for this PD1 your V is constant, right? Now you are having I cos theta is also constant as per this diagram, because both the current I max and I mean are collinear with this V by, actually this is not V, it is V by R. So both the current are in phase with V, so their power factor is 1. But PD1 represent only one, physically PD1 represent one power, not the two power. Means either it should be VD I mean, and otherwise it can be V constant I max. And if we are having I mean not is equal to I max, this is leading us to an impractical or like condition that is not realizable. Yes, it is actually not realizable. Why? Let me tell you. Because we have to draw the current for this. We have to consider an angle gamma from this line. This is the line V by ZS. From this we have to measure an angle gamma and draw a line just a minute. Yes, so this gamma, this actually gives us the stability value. This gamma gives us stability information. So any current that is above this gamma, means you can say that any current that is greater than this gamma value will not be considered, right? So what, this is the case. Now here only we will get the value of current for which our means. So if we think about variation of voltage, we have to consider that all the currents that are below this gamma limit, actually I have drawn up means I cannot draw it clearly. It is not means the line. It should be something like I am trying to draw it. Yes, now it is somewhat clear that almost it will means make it a half, like half portion is within your stability limit. So you will get means current only for this portion. For other end, you cannot have the value of current. Right. So for this is practical, and for unity power factor, we will only have this I mean. Interestingly, and it is quite obvious that with respect to this line, any current that will fall in this region will give us lagging current, and all other current in this side will be leading current. Now, then obviously, it is also gives us a very interesting observation. Like if this is leading and lagging, see one thing here, one more observation we can make, and that is quite important. Like, so maximum value or maximum lagging power that you can have as per my diagram, if we consider this line as our stability line, this is our stability line. So this is the maximum lagging power factor that we can have, and this entire region we are having for leading current. So it is also very interesting and to note that for leading current, our scope of varying this E naught is quite high. Like we can vary E naught to any extent, but for lagging current, we cannot vary it. For a given power, scope of varying E naught is not means quite high. So why so? Like obviously, you if you follow the book of Bhimrat, you will do some inverted V, uninverted means many things, many interpretation he will give. But my question is that while we can have a maximum value of leading current like this much, see this is the value of leading current that we can have for this machine. We can have this is the maximum value of current within our permissible limit, Well, I think this will work here. Yeah. So this is the maximum value of current, permissible current for leading load. Now it is indeed very interesting to note that here means what you are having, that is quite kind of what to say, like it is quite interesting, because for lagging you cannot have a very high value of current, but for leading you can have this one. So what is the logic behind it? That we should think from the physical perspective, that what about saturation and other things is there. Now if we are talking about finding out maximum and minimum excitation for a given power factor, then just a minute, let me insert one more picture. So for a given power PD1, we can have two different value. So the value of minimum and maximum excitation can be written like E naught by Zs. This is the length of this line that governs the radius of this F1 or F2. E naught by Zs is equal to, for PD1, if we think about this, we can write V by 2R, that is the length of this one, V by 2R minus plus our radius of PD1. So what I said, if we take V by 2R from that point, E naught, that means this is how much? This is V by 2R. Now at this V by 2R, what about the minimum value? Minimum value is this one. So minimum excitation is given by this. And what about maximum excitation? Maximum excitation is given by so these are the two different values for a given power. This will give you the minimum and maximum value of your excitation, that is permissible. Now another thing that is quite interesting. Okay, I think this is going to be quite a long one. Next day we will discuss the first that what would be the nature of curve if we disregard armature resistance, and then also we try to discuss what is meant by this stability line. We are writing this in form of delta is equal to gamma, but what would happen if delta exceeds gamma? What physically does it imply? What does mean that it's unstable? That we should investigate, and also we have to think about the this kind of O curve and V curve construction for salient pole meshing. Unfortunately, for many book you will not find it, and even if you find it, it's an incorrect one. Only in the book of A.S. Langsdorff it is clearly written and mentioned, because Langsdorff was the first person who published paper on this. Actually, he wrote that chapter based on his own publication, and all other books either they skipped it or they wrote something that is utterly meaningless and completely erroneous. So that is why please avoid using this kind of book. If you want that construction of V and O curve for salient pole machine, always go for A.S. Langsdorff.